Namaste and welcome back to our channel, Qubit Educational Services. We are solving the IISER Aptitude Test 2019 Physics MCQs. We have completed 14 of them. Only one is remaining, which we will be covering in this video, that is MCQ number 60. Now before I solve this MCQ for you, I would like to tell you that I have uploaded videos on IISER PYQs right from the year 2017. Okay, that was the first time when this test was conducted. I have prepared subject-wise playlists for physics and mathematics and year-wise playlists for these PYQs, and links to them can be found in the video description of not only this but also every other IISER related video. So I'd like you to watch all of them for a better understanding of the difficulty level and in particular the types of questions that are asked, and of course the approaches which you can use to solve those problems. If my channel is helping you in your preparation for the IISER Aptitude test, then please consider subscribing to my channel, and also please spread the word among your friends who would also be benefited from the IISER PYQs. So with that, let's begin solving MCQ number 60. Two equal positive charges Q are placed at the vertices B and C of an isosceles triangle of base A and height h equal to 3 root 3a by 2, as shown in the adjacent figure. When a charge Q prime is placed at A, it is found that at a point inside the triangle, the net electric field due to three charges vanishes. Vanishes means goes to zero. Vanishes means goes to zero. If this point is at a height h by 3, then what will be Q prime? We have got four options. Okay, two of them have negative charge and two of them have positive. Okay, we can actually eliminate the negative charges right away. I'll tell you how. Okay, at B and C we have got two positive charges, isn't it? Okay, and if at all there is any location inside where the field is zero, it has to be the midpoint of this horizontal dashed segment, right? Okay, so let us first join that point with the vertical segment or altitude, and let us also join that point by or to B and C. Okay, to B and to C. Now observe that the fields due to B and C at this point, what will they have in common? Their vertical components will be same, right? So suppose this is field at that point due to C, and suppose this is the field at that point due to B. Okay, then the vertical components will get added, the horizontal components will get cancelled. As easy as that. Okay, so the vertical components will get added. So let me show two of those arrows here, just to signify that there are two such components. And to counter this, to counter the addition of these two, the point charge at A must be positive, because if it were negative, then it will actually assist and it will increase the magnitude of the electric field at this point. So the electric field due to A must be directed away, and it will be should be twice as big as the addition of the it will be equal to twice the addition of EC bar and EB bar's vertical components. Okay, that's clear. Acha, we'll also need the distances, by the way. We'll also need the distances. So let's call this point P. What is AP? Can we calculate AP? AP will be twice h by 3. 2 by 3 into h. H is given 3 root 3a by 2. 3 root 3a by 2. Okay, so 2, 2, 3, 3. So it will be root 3. Okay, it will be root 3. Okay, root 3. Now we also need to calculate BP. Okay, we also need to calculate BP, and let's say this is D. Okay, so let us consider now triangle BPD. Okay, in triangle BPD, can we say that BP squared is actually BD squared plus PD squared? Yes. PD squared is actually h upon 3, or rather PD is actually h upon 3, and BD is a by 2. So this is a squared by 4, and what is PD? PD is h upon 3. h itself is 3 times root 3a by 2, so h upon 3 will be root 3a by 2. So root 3a by 2 square will be 3a squared by 4. So that will be a squared, so BP is equal to a. Okay, BP is equal to a. So AA, now if you consider triangle BPC, two of its sides are identical, BP and BC, and by symmetry PC will also be A. So it is actually equilateral. BPC, although it doesn't look to be, it is actually equilateral triangle. So what is this angle? This angle is 60. This angle is 60. Okay, fine. So what will be the vertical component of EB bar at P? The vertical component there will be, okay, we'll actually do one thing. We'll actually write the net electric field at P. Okay, we know it is 0. Okay, in magnitude it is 0, but let's now try to find Q prime using the fact. Okay, so it will be 2 times Q divided by R squared. R is A. Okay, but this is not the field there. Okay, we need not consider the horizontal components of EB bar and DC bar because they are getting cancelled. So it will be vertical component. So if this is 60, this angle will be 30. Right, this angle will be 30. Okay. So which component do we want now? We want the cosine component, cos 30. Okay, so 2q cos 30. Now these fields will be pointed upwards, so minus, okay, q prime. Okay, q prime into, what is the distance AP now? We have already calculated it, it is root 3a. So we have to just square it, root 3a squared equal to 0. Right, I hope you know what formula are we using here. We are using 1 upon 4 pi epsilon naught q by r squared r cap as electric field produced at a point r from a point charge q. Okay, r cap is the unit vector. Okay, now this thing will be 0 only because of the box bracket, because 1 upon 4 pi epsilon naught, well, that can't be 0. Okay, so let's simplify this now. 2 into q into cos 30 root 3 by 2 into 1 upon a squared must be equal to q prime into 1 upon 3 a squared. Okay, let's carefully cancel the terms. A squared will go. Okay, 2 will go. 2 will go. So root 3q is equal to q prime by 3. Therefore q prime must be 3 root 3q. 3 root 3q. Do we have that option? Yes, that option is B. And that, my friends, completes our discussion on IISER Aptitude Test 2019 Physics.